Hi guys, day 2 for this week. Today we're actually going to have a pretty short video, and then I'm going to give you guys time to practice. Please ask questions. I am available for video chat or email or whatever you guys need all day today. Just send me an email. We can chat or find a time to video if you guys would like some help with this. But what we're going to be doing today is we are going to be using some of those ways to prove parallelograms that we found yesterday. So what I want to do first is I actually want to go back up to those 6 different ways and just kind of review them really quick so that they are fresh in our minds. So the first one is the definition of a parallelogram. If both pairs of opposite sides are parallel, then we have a parallelogram. Second one, if both pairs of opposite sides are congruent, then we have a parallelogram. Third one, both diagonals bisect each other. If both pairs of opposite angles are congruent. If all pairs of consecutive angles are supplementary. And our 6th way that we did a nice proof on yesterday, if one pair of the sides are congruent and parallel to each other. So just take a look at those when you read through them again, but those are the 6 ways that we can prove that a quadrilateral is a parallelogram. So let's go back to number 6 and look at this proof. So we want to use the properties of parallelograms in the following proofs. So we are given that triangle MJK is congruent to triangle KLM, and we want to prove that this is a parallelogram. So let's go ahead and set up our proof. So I have my statements, and I have my reasons. So first thing, I'm going to just write my given. So I'm going to say triangle MJK is congruent to triangle KLM. And my reason for this one is going to be given. So what I can look at next, if I know I have 2 congruent triangles, then by CPCTC, I know that their corresponding parts are congruent as well. So for my statement number 2, I can say that JK is congruent to ML. So segment JK is congruent to segment ML. And my reason would be CPCTC. And I can do the same thing with my other 2 pairs of opposite sides. I can say that for statement number 3, segment KL is congruent to segment JM, and that reason number 3 again is going to be CPCTC. And I could always double check and make sure that those are really my corresponding parts. So if I look, this is JM, this is KL in my congruent statement. Those segments are in the same place in their congruent segment, so that's okay. JK is in the same place in my congruent statement as LM. So I know I didn't flip my triangles around any funky way. And if we think about those 6 ways to prove, I do have enough to prove that MJKL is a parallelogram. And my reason number 4 for this one is going to be because both pairs of opposite sides are congruent. Awesome. So let's take a look at number 7. So number 7 it looks a little bit scarier because there's a little bit more pieces, but it really isn't any harder. So I want you guys to take a look at this and see if you kind of have an idea. So pause the video for a second. You don't even have to write out like a proof, but just kind of walk through, see if you can come up with some ideas for the proof. Okay, so number 7, I'm going to set up my statements. And I'm going to set up my reasons. So my statement number 1, I'm just going to write all of my givens. So just to kind of reread this problem with you guys, I'm given that segment AB is congruent to segment CD. So AB is congruent to CD. I'm given that segment BC is congruent to segment AF. And I'm given that angle AFD is congruent to angle ADF. And all 3 of those are going to be given. So I'm just going to write them all 3 in my step 1. So step 2, I'm trying to prove that ABCD is a parallelogram. So I'm trying to prove that just part of this image here is a parallelogram. So one thing that I noticed here is that I have this triangle ADF over here. And I know that I have 2 angles of ADF that are congruent. So what I can know from this is I can know that segment AF is congruent to segment AD. And my reason for this one is going to be the converse of my isosceles triangles theorem. So remember what the isosceles triangles theorem states is that if a triangle is isosceles, then the 2 base angles are congruent. So if I'm looking at the converse of that, if 2 base angles are congruent, which it would be angle F and angle D, then the triangle is isosceles, so we know that AF is congruent to AD. All right, next part, statement number 3. I'm going to mark that congruence in my image. So I know that AF is congruent to BC. That was one of my givens. I know that AF is congruent to AD. That's what I just found. So I also know that AD, segment AD, is congruent to segment BC. And my reason number 3 for this one is going to be the transitive property. So the transitive property of congruence. So if we take a look here, I have that BC is congruent to AF. AF is congruent to AD. So I know that AD is congruent to BC. I have that connection in the middle. All right. So now I know that AD is congruent to BC. I know that AB is congruent to DC. So what I know, my step 4 here, I can know that ABCD is a parallelogram. And my reason number 4 is going to be both pairs of opposite sides are congruent. So guys, these are the kinds of proofs that we are going to be doing in this unit. So there's nothing scary. We're just using some of those new properties. So go ahead, go to that homework assignment in Google Classroom and give it a try. I definitely think you guys are all going to do a great job, but please let me know if you have any questions or if you need any support from me. I'd be happy to help you. Have a good rest of your day, guys.